Hey guys and girls, welcome back to another beautiful video on this beautiful channel, on this beautiful day. How you guys and girls doing? Hope you're doing great as always. Please check out the description box for all the nice links. Also drop a like, subscribe if you like the content. Check out the top right eye for even more links. And here we go. So this video is by popular demand. A lot of people want a clear explanation on classes. I do have videos on this already, but this one will be a little more revised and a little more all-encompassing. So let's try this out. I'm going to use Visual Studio 2019 Community. If you don't have that, you probably can get Visual Studio Code. It's a nice multi-platform application IDE that you can use or code editor. But I'd recommend this. It's really easy to use. So, you know, I usually use this in my development videos. So let's go ahead and start whatever IDE you have, create a new C++ file, and we'll just call this main. Of course, very easy, right? Let's just get to it. We don't have to worry too much. You probably already know all this stuff. So I'm going to do IOStream. I'm probably going to include string as well, so we can use a few things in main, and we're ready to go. So here we go. Now, classes can be really scary for people. Classes are huge. They can be like daunting. You don't know how they work, you don't know why they're there and all that stuff. So let's go through the very basics first of all. I like to think of a class as a blueprint to a house or a car or whatever you want. It's a blueprint. It's not the actual car, it's not the actual house, it's not the actual product that you want to develop or that you have physically in your hand or whatever that you can see. It's the plan of an object that you can create. And following a blueprint is always exact. When you build a house, you always follow a blueprint exactly. And after that, you will have a nice house built. You'll have a nice car. You'll have a nice whatever the hell product you're trying to create. So that way, thinking of it as a blueprint makes it a little easier. It's not the actual object. First, that's the first thing. The second thing is where to create your classes. A lot of people freak out over this. You can create them anywhere you want. You don't need a CPP file, a header file. You don't need anything. You can create it wherever you want. The reason people create it in a CPP and a .h, the header file, is because they want to organize their code. They want to make it look nice. They don't want everything in one file. They want to make it look real cool. So that's why. I just want you to remember that. You don't have to create it in a certain space or place. You can create it pretty much anywhere you want. You can create a class in any file you want, basically. What you want to do though is you want to create classes globally. So you don't want to create them in a function. You want to create them in the file, but outside any function like this. So if I were to create it in my main.cpp here, let's start off with a very basic class. And we'll call it person because everyone can relate to a person, right? You are a person. You probably know a person, hopefully. You probably have friends or siblings that are person. So we'll have a person class. And like I'm saying, it's a blueprint for a person. And the syntax, the rules for creating a class is usually you write the class keyword, you write the name of the class, and then you do the end and brackets. The beginning and end brackets. And if you're creating it like this in a main.cpp file, in any CPP file, you need a semicolon afterwards. Remember that. You might get a lot of errors because of that. So if you create it in a CPP file, always remember the semicolon afterwards. So this is a class. It doesn't contain anything. This is just an empty person. It's totally empty. It doesn't even have a name, anything like that. So that's the rules, right? Now, if we were to create, we want to create a few things. Now, if I want to create a name for a person, for example, and an age, let's do that. It's a very simple person. I'm going to use the private keyword and a public keyword. And usually you'll see this in classes as well. This isn't a must. If you don't do any of this, everything will be public. Now let me explain the different things that you have here. You have protected, you have private and public. This might seem very scary, daunting, but don't worry. These are folders. These are ways to organize what is in your class. Whatever is under these will be the status it gets. So if I put something under protected, this is a special case. This is something you use when you inherit stuff. You use classes for inheritance, but that's a whole nother video. So we can just ignore protected for now, but it's a good thing to use when you're using inheritance. Private is important though, because a lot of people use private. I use a lot of private. Private means that you cannot directly access whatever I write in here outside of the class. You know these two squiggly things? that's within the class. I can access whatever I write in here within the class, and every function that it contains and everything I do in here, I'll be able to access. But outside, in main or anywhere else, I will not be able to access it directly. I need to create something called getters and setters, and we'll get to that as well. But first of all, it's important to know that's why this is for security reasons. You don't ever have to use this if you don't want, but it's a good way to code. You secure the things you write here, and then you do public things. Public, of course, are things that you'll be able to access outside of the class and inside, of course, but also outside mainly. That's of importance. So here is your connection to the outside world from this, any object that is created by using this blueprint here. We'll be able to access from the outside. So let's see what is important to have in the private section. Usually I have my variables here. So I do a std string, or let's include iostream. You know what? Include, or no, sorry. Using std, using namespace std. I don't use this anymore. That's why I've forgotten how to even write that. So we're not going to do std here. We're going to do string name under the private section, and int age under the private section. And I'll show you the difference between these in a bit. So now we have two variables to work with. If I created a person, this is how you create something out of a class. You write the class name, and then your variable name after that, okay? And then equals to whatever initial value you want. So person, my person, or first person, or any kind of name you want to put in here, equals some kind of starting value. But we don't have anything to do that with. We'll just do person, my person. What happens here? What happens when you do this? Well, you're telling the computer, I want to create something of the type person with this name, this identifier, and then it should call the constructor for this class. And each class has a constructor. We haven't created that yet. There is a default constructor created for all of these. It will look just like the one we create almost, but that default constructor doesn't do much. It just allows us to do this, but it doesn't set anything in our variables that we want. And a constructor is just like it sounds. It's called when the object constructs using this class. So if I were to create my building for the first time, or when my person is born, this function is going to be used. And there's of course a destructor that when our building collapses and its purpose, as well as for the person, which is very sad, but that would be called then. So at the time of destruction, it will be called. Time of construction, one thing will be called, and at time of destruction, another thing will be called. So that's it. That's good. Now we'll keep this my person thingy, and we can remove this. Now let's create our constructor. So the way to create a constructor is always write the class name. Person with two of these ones, two of these things. And since we're creating this in the CPP file itself, you can't really divide it up. So you have to define it here as well. You have to declare it and define it in the same place. And that means we have to write the header here and also the functionality for it. So very good. It's not initialized, of course, but what we'll do here is we'll say name equals NA, because we haven't given a name yet really, and age equals 0 or 0, like that. So there you go. Now we have all of these things that we can use, and we're initializing all of our things in here, and that's what the constructor is for. The first thing called whenever you create it, and what will happen when you create it. So I'm just giving some default values to this name and age variable. And a good thing I do usually when I'm working in classes is always use this. And the this pointer is a whole nother story, but basically what the this pointer is, it's pointing to the current instance of the class. And it signifies for me and for a lot of people that I'm trying to access one of my member variables. So this is called member variables, and these are all member functions. You can write member variables in here as well. You could write int lol, that would be a public member variable. This is a private member variable, and so on. So now, without further ado, we have a default constructor. Now we're gonna create a default constructor. Let's see here, person. So that's how you write a destructor for a class with this squiggly thing in the beginning, and that doesn't do anything really, but we can do something in here. We can do std cout. I don't need std, I always forget that. Destructor called, and then we'll do a new line. And in here we can just signify, we can tell ourselves when the constructor is called. So there are two different things here, and we'll see automatically. These two are always called automatically whenever you create it or whenever it goes out of scope, meaning when it's destroyed. So there you go. And now let's create some regular functions as well. But first of all, let's run this. Let's see if it even runs. So when you run this, what will happen? Step by step, the constructor will be called here. And then when the program ended here, the destructor was called automatically. We didn't call this. Very simple, very simple. So once you're down with that, once you understand that you have created a blueprint for a person, and here you're using the blueprint to create an actual person, that person object contains these member variables that you can change and use, and they are specific for this person object. You can use this blueprint for another person, my other person, and that will be created. But these two member variables will be instantiated for this object. So whenever I change this object's age, this object will retain its own age. That's the beauty of blueprints. You can use one blueprint to create several buildings, right? And those buildings all have their own rooms and inhabitants and different addresses, but they're still built out of the same blueprint. And that's how you can think of this. So now to change our values here and to get them out. Usually I create something called accessors and modifiers, but they're basically getters and setters, which you might be more accustomed to. Very simple. And they're always built by you to get and set private variables. There's no point in having accessors and modifiers when you have public versions, because if I try to get my person dot anything, I won't be able to call anything that isn't public. See, I don't see age here, I don't see name here, because they're not public. If I were to put these under the public section, okay, look at what happens here. My person dot age and name show up here, and I can change them freely. I can set age to 20 here, and it will do it. It will access this variable for this object and set it. But I don't want to do this. This is dangerous. Using getters and setters allows me to have some control over what's going on, because getters and setters are a little easier to call and understand that you're actually calling. This is what I'm doing here is actually something I want to do. So let's create an accessor, and very easy ways to do that, which you would probably see in school or you see in other videos, is just writing the type of what you want to access. So in my case, string for name, I'm writing string, and then usually you do get and the name of the variable after that. So get name, but of course we're doing a big N, capital N, to difference that, to put kind of a space type thing here, right? You know how to do that. So let's just do that, get name, and then you do empty parentheses, and that's pretty much it, right? That's your accessor. Of course you have to define it here. We're going to define it in a few different ways. First of all, we're going to do return name here. You can do return this name to make it clear that you're returning this name, the one belonging to the class, and not a random variable. Of course, there's no random variable here, so you don't need to use this, but I do it for clarification for myself. Now, this is a perfectly good accessor, perfectly good. But when you're defining a class like this in one file, usually what I do is I put this all in one line, okay, and I do something called inline here, because it reads this as one line, and it's a little faster, it's a little better if you're doing accessors like this in your file, in one file. So there you go, that will be defined perfectly nice, but the other way is also very good. Another thing to think about when you're creating accessors is remember that you want to probably return a constant variable and a reference to that variable, and also tell the application that this function is not changing any variable. So there's a lot of things you can do here. Writing const after, let's say we do it like this, like the other way. Writing const after the name of the function tells the computer, or this application basically, that this function will not change any member variable. All right, it will not do any change to anything here, any of these member variables in this function. So it guarantees that. This constant saying that whatever we're returning, the string we're returning, return it as a constant. So we can't change it outside. All right, it's not possible to change it from outside. And the reference basically says, don't send this as a copy of itself, send it as a reference. So it's a little faster, it's a little more optimized because we're not copying this variable. We're actually sending an alias to this exact variable out, and we're sending it as a constant so you can't change it. And we're not changing anything in here. So this is a very optimized accessor, and get used to writing them like this. And of course you can use the inline if you're doing it in one line there. Now we're gonna create a modifier for name, and I'm gonna do it by starting off with void because we're not gonna return anything. We're gonna modify a value here, and those are usually started with set name. Very nice. And we're going to optimize this as well. So whatever we're getting in will be a constant value. We'll write name, const string name, sorry. And then we'll have a local variable here to work with. Now, notice one thing. This name is exactly the same as our member variable name. So how would you differentiate that in your function? Usually the application takes the local variable first because it's closest. So if I say name equals name here, it will put the local variable to itself. I don't want that. I want to set my member variable to my local variable, even though they have the same name. That's what this is used for, to differentiate those two. This name will look for name, a member variable called name in the class, while this local variable name is here and it just knows that it's the local variable. So we'll use that first. That's why it uses the local variables first before the member variables. So you can do this. And that way you don't have to create different names for these variables. And this is a very nice optimized name accessor or modifier, sorry. We don't use the const here after because we're changing a member variable within the class. But this is constant because this name's local variable is coming in as a constant. You don't have to change this in here. So that's good. Perfect. Now we have a modifier and a accessor. Let's just duplicate these for our age. So get age. We'll have to change this to an integer and then return this age instead. So try to sync that, and hopefully you'll understand because of my explanation before. We're going to create a modifier for age as well. Set age, const int age. And remember, these integers and strings are very important because it matters what type your variable is, member variable is, because you're trying to set that, right? So be careful with that. This age, very good. Now once that is done, now we have accessors and modifiers for these. We have two different people here. They all start with 0 as age and NA as name. And what we can do is we can create a nice function here, returning a const string, to string is what I call it. So it's a nice way to print out whatever variables you have. I'm going to do that, and I'm going to put a const after it because we're not going to change anything in the class, in the function. And what I'm going to do basically is I'm going to return a string, this age or this name. So name, like that, plus age, and then plus to string this age, like that. So we're going to return a nicely formatted string of our member variables, and we can call this and print out my toString function easily, showing what my person contains. Cout my person dot toString and a new line. And I can also say that this is my person, like that. And then I'm going to copy this and put it down here. And as you can see, each of the functions are also part of the blueprint. So each object here will call the same function with same name, but it will use their own specific variables to print things out. So if I do my other person here, we'll see the difference between these. Let's just run this and let's see what's going on. Here we go. Constructor called. My person is created. The name is NA, age is 0, of course. Constructor called for my other person. Name is NA, age is 0. Destructor called, destructor called. Both objects are destroyed here. And that's good. They have the same values. Perfect. Very nice. Now to set things, before we print anything out, let's set my person.set age. Let's set my age to 30. And my person.set name to Suraj. All right. And we'll copy paste this below my other person and just change this to my other person instead. So we'll use my other person's set age and set name. And it's going to be something different. It's a 25-year-old dude called David. Shout out to all the Davids. And we'll run this again. So constructor is called for my person. Name is now Suraj and age 30, while constructor is called for my person here. And then we set the name to David and age 25. Right? So here we go. We have two different people created out of the same blueprint, but they have different ages and different names because we have set them. They all contain their own member variables, specially placed for them, initialized or instantiated for that object. Well, that's very nice and good. So you're setting the age and you're setting the name, but what if you want to do that in one call? This is very important. So constructors can take inputs. And the way you do that is you say what you want in here. I can do an int age, or let's start with the string name int age here. And now we're telling this constructor that whenever you create a person object, you have to require a name and an age. And then of course we'll set this name to name. Don't forget that. And this age to age. Now we can remove this constructor call or comment it out like that. And we'll set whatever incoming values are coming in here, we'll set our member variables to those values. So an example of this, now it's going to complain. It's saying no default constructor exists for class person. And the default constructor is an empty constructor. All right. We can create one of those as well. You can have multiple constructors as long as they're differing in their inputs, but they have to always have the same name. They have to start like this, person. And I can do this in the default constructor. I'll say name equals NA, like that, whatever. Age equals 0. There we go. Now I can create the person object in two different ways. All right. I can even create one more constructor here if I want that takes this, or sorry, string name only. And I'll put name to something, but I'll keep age at 0. So as long as they have different input variables, they are different constructors. That's how you define a constructor as different. So we have three different types of constructors here. Let's call our person the big one that we created here. Let's go down to where we create the person, and let's say, now it's not complaining by the way, because we created a default constructor for it. So it can use that if it wants. So this is the way we can use to create different types of objects using different constructors. Now we're gonna give it a name, Suraj. And let's give it age 32. I've aged a little bit. And let's create this person using the same constructor, but call him Kim with the age is a 14-year-old right here. And now we'll run this again and we'll see that we use the constructor now to access or set those variables. You see we have different values, right? That's a few ways you can create your objects. Beautiful, very nice. Now we have just one last thing I want to talk about, and that is called an initialization list. Sometimes using that is very important. So I want you to know that it exists. And the way you do that is then you don't initialize them inside the body here. What you do is you write a colon and you write the name of the variable you want to initialize. So name, for example, and you'll set it to something, NA in parentheses like that. Comma to set another variable, age, set it to 0. And this is called an initializer list. And this is very, very important to use in certain scenarios. So you'll see that you'll have to require this, for example, when you're setting a reference here or something like that. So especially for references, you need to use this. I'm not going to show you that example here. This is not what this is about, but initializer lists are great to use. I'll comment that. Initializer list, initialization list, or initializer list. And that's the way you do it. You can do the same thing here. For example, I can do the same thing here. Name, age. So it will know how to differentiate those. The thing outside is the member variable, and whatever is inside the parentheses is the local variable, the parameter. And then you don't have to do this because it's done even before the body here. Okay, so that's a good way to initialize things. You should get used to this actually. It's a very good way to do things. So remember that. Now you have had a nice explanation of classes. Of course, you can create any type of classes you want. So I'll make a separate video on how to divide your class up into several different files, but just to give you a quick example, what I usually do is I usually use the class wizard to create new files, and that automatically creates the files you require to put them into different files. We could do it manually. We can create a person header first of all. So what you do, you create a header with the same name as your class, so person, and you add it, and it'll just be an empty file. And then a source file, you add a new item here, you say CPP file, and also give it the same name, person, add it. But in this person CPP, you want to include your header file, person.h. And in here, you want to include whatever you require for that class. Now, in our case, what we would do, we would take this and we'd put it in here like this, and we'd have to send all of these functions and define them in here instead. So we'll only keep the header and we'll put the definitions in here. But to see that, just check out the other video on separating this into files. I think that'll be better. This video is too long right now anyway, so I'm just not gonna save that, and we're gonna keep it in the CPP file. But this is how you can practice with classes. This is fine. In Visual Studio, you can just minimize it, and then you can play around with these. So my task to you would be, some homework to you would be to create a house class, maybe a car class, create a wheel class, and put that inside, create some wheels inside the car, and so on. Try to contain classes and classes. But we'll talk about that as well in the coming videos. But for now, this should give you a good picture of what the class is and how to work with it. So thank you so much for watching. Please take care. Also, drop a like, subscribe if you like the video, drop a comment if you want, and all that. Take care. I'll see you in the next one. All right. Bye-bye.